Hello everyone, and welcome back to the Fluctus channel. For decades, science fiction writers and engineers alike have agreed on one point. The future of warfare lies in robotics and automation. Rather than humans fighting, machines would handle the problematic jobs while being remotely controlled from a safe location. Perhaps the best example of this theory at work is the United States' drone program. One of the first military drones was the MQ-9 Reaper. These state-of-the-art, remotely piloted aircraft were first introduced in 2007 and have since flown thousands of missions worldwide. The MQ-9 looks and behaves much like any other aircraft, except that all movements are sent through a satellite communications link.
He'll drag the weapon with him.
This allows pilots at ground control stations to pilot the drone from extreme distances, sometimes more than a continent away. The Reaper's flight control system consists of various flight computers, inertial navigation systems, and global positioning systems, enabling the aircraft to navigate and maintain stable flight autonomously. The remote control and self-flying functions are not the only benefits of employing drones, as opposed to manned aircraft. Indeed, autonomous aircraft like the MQ-9, MQ-20, and MQ-1 generally require less maintenance than traditional combat jets. That said, they do require human inspection and intervention in order to ensure to avoid system failures during flight. For instance, all drones will undergo a pre-flight inspection before each mission. This involves examining the airframe, control surfaces, payload systems, sensors, and the communication link. Like other military aircraft, the MQ-9 Reaper follows a scheduled maintenance program outlined by the manufacturer. This includes periodic inspections, component replacements, and system checks, with other components being checked and/or replaced regularly. Finally, mechanics will spend a lot of time servicing the avionics of the drone. If, for any reason, these navigation, communication, and control systems were to fail, the drone would eventually crash into the land or sea below. The typical ground control station for an MQ-9 Reaper consists of a series of monitors and control interfaces. When not operating autonomously, it takes two specially trained individuals to work the drone: a pilot and a sensor operator. The latter handles the cameras, runs checklists, and provides support for both the pilot and third-party teams.
Its own quarter. It's only like a very small group. That's not gust factor, so we'll add 4. Actually, we'll add 3.
On the other hand, the pilot generally concerns themselves with managing the drone's direction, altitude, and positioning. Each GCS console features a series of joysticks, keyboards, and switches for operating the aircraft's flight controls, sensors, and other systems.
219er. Payload set to position where the calibrate for landing.
This enables operators to control the UAV's takeoff, landing, navigation, and payload operations, while monitoring and interfacing with the onboard systems. The biggest issue with piloting an unmanned aerial vehicle is situational awareness. Therefore, both pilots and sensor operators undergo extensive simulation training to ensure they can react to various situations without physically being inside the aircraft. While drones are still relatively new to military use, their potential is unmistakable. The main benefit is obvious. Militaries can now launch various missions without risking human lives. Unmanned aircraft also allow for the execution of operations that require entering potentially hazardous environments or high-risk scenarios. UAVs also enhance reconnaissance and surveillance efforts, as drones can utilize advanced sensors and cameras to provide real-time, high-resolution data to pilots and troops on the ground.
Alright, so winds are coming 240, so that was from the left, so I'll offset.
Around the world, drones are increasingly taking to the skies to accomplish jobs that might otherwise be difficult, time-consuming, or expensive. And because most UAVs cost far less than other aerial solutions, even countries with much smaller military budgets can use them to improve their defense and surveillance capabilities dramatically. Some great examples include the drones being developed by 3 Systems, an Estonian-based company that produces UAVs for both civilian and military purposes. One of their leading models is the Stream C, a small drone capable of being assembled and launched by a simple 2-person team using a slingshot ramp. Utilizing a series of ground equipment, this team of professionals can fly the high-powered drone over a wide area while receiving up-to-the-minute data from the various sensors and cameras on board. When the mission is complete, the team can kill the engines and trigger a parachute that will help bring the Stream 3 safely back to Earth for retrieval. This sort of mobility is virtually unmatched when it comes to drones of this size and with this level of capability. Another excellent example of modern drone technology is the Dragonfish Tiltrotor UAV from Hotel Robotics. Hotel is an American-Chinese company that produces simple, effective drones for security, construction, and surveillance purposes. The Dragonfish is unique in that it can turn its rotors 90 degrees, allowing for vertical takeoff and landing, as well as efficient fixed-wing flight. Among the other benefits of the drone are its high endurance, which can last as long as 2 hours, even with a maximum payload, and the fact that it is fully waterproof. Hotel also designed the Dragonfish with versatility in mind. Though many experts consider unmanned aircraft to be the future of aerial operations, they are not invincible. In fact, drones are often more vulnerable than manned aircraft due to the aforementioned situational awareness problems and their inferior air-to-air defensive capabilities. Of course, drones do not need to be as large as the Reaper or its predecessors to perform surveillance or espionage. Even the tiniest drones, many of which are available to civilians, can pose a threat. For this reason, many militaries are racing to develop new, more sophisticated radar technology that can better identify even the smallest drones before they get close enough to cause problems. This multi-role electronically scanned array, or MESA, from Northrop Grumman, is one such device. Designed to be deployed in air-to-air scenarios, this type of radar allows technicians to manage their radar energy to scan deeper into specific sectors and less so in others. They can also revisit points of interest much more frequently, reducing the chances that a drone or other small object might get past their visual defenses. In situations where mountains or other obstructions create weak spots in radar coverage, mobile radar vehicles can be an important prevention method. The Groundmaster 200 is a multi-mission mobile radar vehicle designed by Thales, a defensive company based in France. It is specifically intended to detect, identify, and track potential threats that long-range radar systems might not pick up. This quick identification means troops on the ground or in the air can respond much faster. In a world where even a small drone can cause big headaches for servicemen and women, vehicles like the GM200 are an essential line of defense. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.